Mostly after the the quiz one review, what we learned in last class is just one idea, one concept about atomic structure. Okay, this is Rutherford's model for an atom. So if the atom as big as this shows, then most space are empty, nothing there. In the center of very small space, concentrate the most mass, and this mass comes from proton. Proton carry positive charge. And the electron travel around the nucleus in this surface. Electron carry negative charge. Electron's mass is much lighter than proton's mass, so electron's mass can be neglected. The whole atom's mass comes from proton. Okay. So this is a Rutherford's model. This is most of what we learned in last class. Also just this. And this model left over one problem. If we think about the hydrogen atom compared with the helium atom, from periodic table, if you take a look at periodic table, hydrogen 1 proton, helium 2 proton. Then according to Rutherford's model, their mass ratio should be 1 to 2 because hydrogen 1 proton, helium 2 proton, their mass should be 1 to 2. But the actual mass is 1 to 4. Helium is 4 times heavier than hydrogen. So this result tells us should have another small particle not discovered inside an atom. This is discovered by Chadwick's experiment. He's shooting alpha particle onto the beryllium foil, and the beryllium foil emits a ray. Ray always consists of particle. Very high energy, but no charge. It cannot deflect by electric field. That means no charge. And this particle's mass approximately the same as a proton. No charge. That's why given name is neutral. Neutral, so no charge. Mass is similar as a proton. So according to this result, we explain why helium atom is 4 times heavier than hydrogen. Because in helium's atom, 2 proton plus 2 neutron. In hydrogen atom, only 1 proton, no neutron. The mass is 4 to 1. Okay. So now we have 3 different particles discovered inside an atom. Proton carry positive charge, neutron no charge. Their mass approximately the same. Electron carry negative charge. Electron's mass much lighter than proton or neutron's mass. So electron's mass overall can be neglected, but the electron carry negative charge to balance positive charge from proton. Okay, so actual charge is 1.6 times 10 to the negative 19th power coulomb. This is the actual quantity. Since this is the smallest quantity of charge, either positive or negative, so we just simplify. Proton is positive 1, electron is negative 1. As a general chemistry, you are not required to memorize this. Even in the upper level class, you are not required to memorize this value. I will provide a table. For you guys, you're not required. But you are required to remember proton is a positive 1, electron is negative 1. Another is this positive 1 or negative 1 is not the actual quantity of charge. This is just simplified because the smallest charge is absolute value is the same. That's why we simplify proton is positive 1, electron negative 1. Okay, that's all. So 3 different particles inside an atom. Proton, positive charge. Neutron, no charge. These 2 particles mass is similar. Electron, negative charge. Mass is very light, can be neglected. So as an atom, the mass comes from proton and a neutron. Okay. According to this idea, so any element we use atomic number come from proton together with the mass number in the upper left corner, mass number, lower left corner, proton number. We give name as atomic number. Mass number come from proton plus neutron. So we find hydrogen could have three different atoms: hydrogen 1, hydrogen 2, hydrogen 3. The reason is hydrogen 1 atom, only 1 proton, no neutron, so mass is still 1. Hydrogen 2 atom, 1 proton, 1 neutron, so mass is 2. Hydrogen 3 atom, 1 proton, 2 neutron, so mass is 3. So for those atom from same element but different mass number, we give a name as isotopes. So now you can understand why I use family name member. Explain to you the relationship between atom and element. So very, very good example. At that time, before we learn this, I say not very good because in chapter 1 we learned atom from same element, exactly same. But in Smith family, several brothers, some shorter, some higher, right? Some taller, some different. When we learn this isotopes, now you find this example is actually a very good example. Atom from same element could have some difference because some atoms contains more neutron, the mass is heavier. Some atoms contain less neutron, mass is lower. Right? Okay. This confirm my example is a really good example. Help you understand atom element. Use family member, family name. Okay. So this atom from same element with different mass number we call isotopes. Here is another example. Uranium 235, uranium 238. Still uranium, but mass different. Yeah, this will explain hydrogen 1, hydrogen 2, hydrogen 3. Because hydrogen 1, only 1 proton, red color ball. Hydrogen 2, 1 proton, 1 neutron. Green color ball is neutron. Hydrogen 3 is 1 proton, 2 neutron. Okay. Now, with isotopes, if we write this symbol, carbon 613, carbon 13, carbon atomic number always 6. If atomic number changes, then different element. If we write carbon 613, how many proton? Of course, 6. Atomic number comes from proton. Then how many neutron? Is the difference between mass and proton number. Because mass comes from proton plus neutron, right? So mass number minus proton number is neutron. Then 7. Then how many electron? 6. Because as an atom, no net charge. If you have 6 proton, you should have 6 electron. Then overall, no net charge. And if this is carbon 12, then still 6 proton. Element didn't change, the proton number never changed. But neutron number changed. 12 minus 6 is 6. This is 13 minus 6 is 7. Electron, since this atom, no net charge, 6 proton, still 6 electron. Okay. This is about periodic table. Okay. More than 150 years ago, chemists already find some element behave similar with each other. This is origination to develop the early periodic table. First periodic table is developed by a Russian chemist, Mendeleev. They have a universal name. many live chemistry university or college. Okay. He places element with similarity in the same column. This we call group. Same vertical column we call group. While those elements different, behave in different chemical property and physical property, but they gradually change. Then in vertical, in a horizontal rule, this we call purity. Okay. So modern periodic table place these elements in a table is based on their proton number. Hydrogen is 1, helium is 2, okay. Lithium 3. Okay. But still very similar as the first periodic table. So those elements listed in the same vertical column, we give special name as a group. They behave very similar with each other. Like a group 1A, this, except the first one, all others are very active matter. Very active matter means during the reaction, they very easily lose electron. Okay. Then group 2A, they are also very similar with each other. They are all active matter. Be careful, my words. Group 1A is a very active matter. Group 2A are active matter. That means they're still active, but not as active as group 1A. Then group 3A becomes even less active. Okay. So as we move from left to right along the same period, the properties from very active matter to less active matter, even less active matter, then maybe becomes metalloid. Metalloid means between matter and non-matter. Then becomes non-matter. Then if we move toward the right, it becomes more and more active non-matter. Active non-matter means either in gain electron. Active matter means either lose electron. They are opposites. Okay. So move to the right, it becomes more and more active non-matter. And group 7A is the most active non-matter. That means very likely gain electron, if possible. Then ended with group 8A, noble gas, not active at all. Don't want to gain electron, don't want to lose electron. That's all at this moment. And about the periodic table, we have a separate chapter. It's chapter 8. At that time, we'll discuss periodic table in very detail. Okay. Now comes out a new concept we call molecular. Molecular is an aggregate of 2 or more atoms chemically bonded. Be careful, chemically bonded don't mean just 2 atoms stay together. This is your daily language and not accurate. Chemically bonded, this means these atoms bond with some special format through chemical bond. Okay? Not just put together, that's different. It's your daily language. Here give you some example. 2 hydrogen atoms, we use a small ball. Hydrogen we use gray color. Small ball with gray color, hydrogen atom. Bond which is other through a chemical bond, we use a short stick. Okay. Like this, 2 hydrogen atom bind with 1 oxygen atom. Oxygen uses red color through 2 chemical bonds. And you see these 2 chemical bonds not in the straight line, bended. This 3 hydrogen atom bound with 1 nitrogen atom in blue color through 3 chemical bond. And this is a 1 carbon atom bound with 4 hydrogen atoms through 4 chemical bond. This molecular. The molecular, if only 2 atoms bond to each other, then we give a name is diatomic molecular. Di means 2, right? We learned in chapter 1. Mono is 1, di is 2, tri 3. If more than 2 atoms bond with each other, form this molecular, we just give them polyatomic. Like this. Water, you have 3 atoms bond with each other, polyatomic. Ammonium, 4 atoms bond with each other, then tetra atom. Or more than 2, overall we call polyatomic molecular. Now comes out another concept called R. We just learned molecular, right? Molecular is at least 2 atoms bound with each other form a unit. R, this means either 1 atom carry charge or group of atoms together carry net charge. This net charge could be positive, could be negative charge. If carry positive charge, then we call this R is a cut R. Like a sodium, carry positive 1 charge. This is cut R. If this atom or group of atoms carry negative charge, then we give a name is on R. Like a chlorine, carry negative 1 charge, we call chloride. So why this atom or group of atoms carry negative charge or positive charge? That is because sometimes this atom or group of atoms lose electron, like a sodium. Initially 11 proton, 11 electron. This atom, no net charge. Proton, electron exactly the same, balanced. But when sodium met with non-matter, sodium lose electron. Non-matter gain electron. Okay, by the way, active matter means lose electron, either lose electron. But the active non-matter means either gain electron. Okay. So when matter met with non-matter, matter lose electron like a sodium, lost 1 electron. Lost 1 electron, now just 10 electron left, right? But you still have 11 proton. So 11 proton, 10 electron, 11 proton, 10 electron overall. Negative 1, positive 1. On the other hand, on the other side, for chlorine, 17 proton, 17 electron. Chlorine is a very active non-matter, tends to gain electron. Gain 1 becomes 18 proton, 18 electron. Then overall negative 1, because protons still same, 17. 17 proton, 18 electron, 1 extra. So negative 1 charge. Again, keep in mind the protons positive 1 charge, electron is negative 1 charge. If you have extra 1 electron, it's negative 1. If you have more protons than electron, then it's a positive charge. Right? Okay. If this is only 1 atom, then we give name as a monoatomic molecular. A monoatomic R. Mono means 1. Di means 2. Right? So like a sodium R or chloride R or calcium R. Anyway, only 1 atom. The charge could be 1 or positive 1 or negative 1 or positive 2, negative 2. This mono means number of atoms. If more than 1 atom together carry charge, we call polyatomic R, like OH together, negative 1 charge. CN together, negative 1 charge. NH4 together, positive 1 charge. Polyatomic R means more than 1 atom together carry charge. Okay, so now if we write a symbol like this, aluminum 1327, 3 plus charge, how many proton? Proton never change, always this number, lower left corner. This we call atomic number, come from proton number. How many neutron? Always the difference between mass and proton is 14. The difference is electron. If no charge, aluminum atom, then electron equal to proton number. But now 3 plus charge, what does this mean? What it means 3 plus charge? I forgot. 1 plus charge means lose 1 electron. So electron negative, lose 1 negative over positive 1. Right? If lose 2 electron, the positive 2. If lose 3 electron, positive 3. If gain 1 electron, negative 1. If gain 2 electron, negative 2, right? Now, 3 plus charge means lost 3 electron. Initially 13, lost 3, of course, 10. For this symbol, bromine negative 1 charge, 35, 79. 35 is a proton. Mass, the neutron is mass T minus proton. 79 minus 35 is neutron. Electron, 35 plus 1. Be careful, minus means gain extra 1 electron. Okay, so 35 plus 1. Okay, you need to keep in mind, whenever you see a minus charge, minus 1, you need a plus 1, because minus 1 means gain 1 extra electron. Minus 2, gain 2 extra electron, you need a plus 2. Okay, not minus 2, is plus 2 to the proton number. You get it? Here shows some non-atomic ions. So group 1A actually includes hydrogen. Tends to lose 1 electron, becomes a 1 plus charged ion. Group 1A, a very active matter, tends to lose electron, lose 1 electron, cause 1 charge. Group 2A, still active matter, but not as active as group 1A. How many electron lost? 2. Group 2A lose 2 electrons during the reaction, so plus 2 charge. Right? If we take a look at this right side, group 7A, they tend to form negative 1 charge. This means they tend to gain 1 extra electron. Group 6A, gain 2 extra electrons, negative 2 charge. Okay. Okay. In chemistry, we normally use molecular formula. The right equation to show you how reaction happens. So molecular formula looks like this. How many atoms from each element bonded to form this unit? Hydrogen molecule. 2 hydrogen atoms bond with each other. This 2 is a low corner. Okay, low corner. Low corner we call subscript number. Like this, H2 or O2. In the low corner we call subscript. In mass, we have another format, right? What does this mean? 5 second power, right? This 2 is the upper corner. This we call subscript. This is math, this is chemistry. Okay. Chemistry, we use a subscript number to indicate how many atoms bond with each other to form that molecular. Like H2 means the two hydrogen bond with each other form H or hydrogen molecule. H2O, two hydrogen atom bond with one. New number means one. With one oxygen atom form water molecule. One nitrogen bond with three hydrogen atom form ammonia. So most cases we use this format we call molecular formula, tell you how many atoms from each element to form this molecule. Sometimes we use structure formula, still element symbol, and tell you how these atoms bond with each other. We use a short stick to represent chemical bond. Hydrogen bond with hydrogen through this single bond. Hydrogen bond to oxygen, then bind to another hydrogen, two single bonds. Nitrogen bond with three hydrogen, so three chemical bonds. So this is still very easy and clear. Sometimes, very rare case, especially for those beginner in chemistry, we use this format we call a ball stick. We need to draw a ball, very in different color, to represent different atoms from different elements. The gray color represents hydrogen, two hydrogen bond with another two hydrogen bond with each other through this bond with short stick. One oxygen bond with two hydrogen, red color oxygen with two hydrogen. One nitrogen bond with three hydrogen, with blue color represent nitrogen. With black color represent carbon. Okay. So this is not as easy as this because you need to draw a ball very different color. Use short stick represent a chemical bond. And sometimes we use this similar as this, but no short stick. This ball stick together or space filling. So these two models not very common. Sometimes very rare case, especially for those beginner, tell you how this reaction looks like. Okay. Again, most popular format is the first molecular formula. That's the easiest way in writing and in understanding. So previous slide tells us what is a molecular formula. Tells you how many atoms from each element chemically bonded, right? So molecular formula tells the exact number of atoms from each element bonded with each other. But in chemistry, sometimes we use empirical formula, which only shows symbol is the whole number ratio of atoms from each element. Sometimes these two formulas exactly the same, but most of the time they're different. For example, for water, H2O, two hydrogen atoms bond with one oxygen atom. Can we simplify this number ratio? We cannot. 2 to 1, how can you simplify? 1 is the smallest whole number. You cannot simplify. So empirical formula is exactly the same as molecular formula. Because 2 to 1 is already symbol is the whole number ratio. Most case will be different like this. C6H12O6. This is sugar. This is symbol is the sugar, glucose. Okay. If anyone with diabetes, this person need a test or monitor blood sugar. That blood sugar is glucose. So chemical formula is C6H12O6. This is molecular formula. Then according to the definition of empirical formula, Can we simplify this? 6, 12, 6. Of course, everybody divided by 6 becomes 1, 2, 1. Right? So empirical formula is CH2O. No number, again, no number means 1. One carbon found with 2 hydrogen and 1 oxygen. Just as simple as the whole number ratio. The actual number is 6 carbon minus 2 hydrogen and 6 oxygen. Similar, this N2H4 simplify as 1 to 2. Everybody divided by 2. From molecular formula to empirical formula, you simply divide by every other number by common number. Like for this example, the everybody divided by 6. Then this everybody divided by 2. This is most case. But if this molecular is only one element, like O3, how can we simplify? Oh, if it's O3 or one element, of course, divided by same number becomes O1. Okay. Give you one more example. We give O3, right? Then how about O2, H2? What is the empirical formula? Huh? Just H, yeah. Divided by 2. Okay, we have molecular is this. S8 means 8 sulfur atoms bond with each other form a molecular. Then what is the empirical formula? Just S. Okay, this is a special case. It's only one element. Just divide by the number. Only one element. Empirical formula are always 1. Okay, always 1. If this molecular only contains one element. Next, about ionic compound. Okay. First, we learn compound, this concept in chapter 1, right? To qualify as a compound, must have at least 2 different elements. Right? If only one element, like H2 or O2 or S8, this is not a compound. Even though they are molecular but not a compound, right? To qualify as a compound, must have at least 2 different elements bonded with each other. Then what means an ionic compound? That means this compound contains cation and anion. Cation carry positive charge, anion carry negative charge, and these 2 charges must be balanced as a whole compound. No negative charge. That's why the total positive charge from cation always equals to total negative charge from anion. As a compound, no net charge. Net charge is 0. Another thing is, ionic compound formula always same as empirical formula. Here, give example is sodium chloride, which is table salt. Table salt as a very good example to tell you formula. We know table salt, the formula is NaCl, right? NaCl. This means 1 sodium, 1 chloride. But the actual structure looks like this here. Looks like this here. If this red ball represents sodium, then gray ball is a chloride. Chlorine in compound we call chloride. We'll learn naming compound very soon, maybe in next class. You find each red ball surrounded by 6 gray colored balls, right? Left, right, front, behind, top, and bottom. If you take a look at gray ball, also surrounded by 6 red balls, right? 1, 2, 3, 4 top and bottom. So each sodium surrounded by 6 chloride, while each chloride also surrounded by 6 sodium. Then we should write the formula as right. Then simplify NaCl. So this explains why ionic compounds always have similar formula as empirical formula. For any ionic compound, total positive charge always equals to total negative charge. Then if we simplify, then you get empirical formula. Okay, so here is an example for some ionic compounds. Al2O3, aluminum oxide. Is this satisfied total positive charge equals to total negative charge? Yes. Oxygen, group 6A, previous slide there is group 6A tends to become -2 charge, right? Again, 2 electron, -2 charge. The 3 oxygen total -6. While aluminum from periodic table, group 3A, then tends to lose 3 electrons, so positive 3. Positive 3, you have 2 aluminum, then positive 6. Right? So positive 6, -6. Balanced, no net charge. And is this same as empirical formula? In other words, this formula can be simplified. No, 2 to 3, you cannot simplify further. So this is an empirical formula. Let's say this, calcium bromide. Calcium from group 2A, if you take a look at periodic table. Group 2A loses 2 electrons, so positive 2. While bromine, where is the location in periodic table? Group 7A, gain 1 electron, right? So -1, but you have 2 bromine there, -2. Calcium positive 2, balanced. And the formula is the calcium is 1 bromine, here is bromine is 2. 1 to 2, already simplified. This is sodium carbonate. CO3 together we call carbonate. Okay. Sodium from group 1A, right? Positive 1 charge, 2 sodium, positive 2. Carbonate CO3 together, -2. Still balanced. And can this formula can be simplified? No, it's already symbolized for temperature. So these 3 examples tell us for any ionic compound, total positive charge always equals to total negative charge. As a compound, no net charge. And ionic compound is a formula, always is an empirical formula. This explains why we need empirical formula. Another reason why we need empirical formula is in order to experimentally determine molecular formula, you have to go through empirical formula first, then determine molar mass, then figure out a molecular formula. Of course, at this moment, you don't know what it means molar mass, because this will be learned in chapter 3. Okay. So now I just explained to you why we need empirical formula. First reason is ionic compound, the formula is empirical formula. Second, if this is not an ionic compound, we want to determine molecular formula. we must go through empirical formula first. Then need one more step to figure out molecular formula. Right. In chemistry, most cases logical. Why we need this? Because some reason. Right. Most cases logical. Sometimes not very logical. Let's say in chapter 1 we learned element name and symbol, right? Element name and symbol. This like hydrogen symbol is H, come from first letter. Oxygen symbol also come first letter. And some come first 2 letter. Calcium. Ca. It's logical, right? But sometimes not logical. What is symbol? You may not remember. This Cu is not CO. But we do have CO. Cobalt, that's right. Cobalt is CO. Sometimes completely not logical. But no relationship with the name. But what else? This is International Chemistry Association, Pure Chemistry Association. Anyway, this is they determined. We as a student or just a regular professor, we need to follow these rules. Okay. If you become the most famous chemist, or especially a group of most famous chemists, you can write some rules, then others follow you. Okay, only 3 minutes left. Let's just stop here. Okay, have a good weekend.